Welcome, everybody. I don't normally love standing behind a podium because I feel like you can barely see me. But hello. Today I'm going to talk to you about the Changing Landscapes Initiative and applications of a case study in land use planning and conservation. So in the summer of 2016, my very close friends, the Ringo people, that's a gift name for them, were inundated by a flood in Louisiana, woken up in the middle of the night and told to leave their home. Here, earlier this year, April 1st, 2017, there was a landslide in Mocoa, Colombia, killing upwards of 250 plus people. It's hypothesized that the cause of this landslide was the development on this very steep hillside, as well as along floodplains. I bring these two examples up because they serve as an example of the importance of land use planning in the preservation of ecosystem services, such as erosion and flood control. So our challenge as conservationists is to both preserve nature as well as communicate the importance of preserving it and the benefits that it provides to human health and well-being. This is the goal of the Changing Landscapes Initiative. I want to present this here to you today as a case study in the study and fulfillment of that greater goal. So our primary approach is called scenario planning. This basically involves involving stakeholders throughout the entire process, but primarily in the scenario building part of this process. We start with describing the landscape, working with them to develop scenarios, and then combining that with land use land change models to model potential futures. And then the ultimate goal is really to guide regional planning efforts. So this is for the preservation of ultimately the services, but as well as the function and the biodiversity that supports that function all the way through the line. So step one, how is it that we describe this landscape? Well, our study area is focused in northwestern part of Virginia. It's a 15-county region that has 3 major tributaries that lead into the Chesapeake Bay. We focus on 4 major land cover types in our land use land change modeling process, and here I show you them in these 4 major classes: forest, grasses, cropland, and development. We also incorporate several variables. These are dynamic as well as static variables on the geography, ecology, and also socioeconomic status of the area. Scenario building is where the stakeholder expertise really comes in. So we bring these stakeholders together in a suite of meetings, and they brainstorm drivers of change that influence land use land change planning in the area. They rank these drivers on order of impact and uncertainty relative to each other, and then from this they actually produce quadrats by intersecting the 2 drivers together. So for every particular driver, there is a high and low end of extremes. So for example, for population growth, it would be high or low influx or exflux of population. Now the stakeholders take this information and then they're each assigned a quadrat. They're split into the groups and they envision a potential future. So down here you can see a couple of illustrations. We give them paper and crayons and pens and they get to play, and it's like story time for adults for an entire day. Down here is just one example. They call this Feudal Valley, and here is a low number of people, an unsuccessful adaptation to climate change. In many of the cases, we were very lucky that the stakeholders actually fulfilled the ultimate process for these workshops, and they produced storylines that were actually in the form of newspaper articles. So they were fun for us to deliver to our funding agencies and supporters, and I think it was really fun for them to participate into as well. So here's what we ended up with at the very end of these workshops. We have 2 major drivers. These are political will and population growth. So population growth runs along the axis of extremes, high and low. And then political will we defined as either opportunistic or ad hoc or strategic planning. So we developed, with their help, a suite of 4 scenarios that fulfilled those quadrats, those intersections, and they're described here. So centralized development means basically we're promoting the pushing of development towards urban centers. Suburban sprawl is like it seems, like it sounds, spreading of development across a landscape and fragmentation of habitat. Production valley is where the Shenandoah Valley really turns to crop and cattle grazing and also chicken farming. And then natural and cultural resource export is where we have strategic planning but very low population growth. So our region ends up being a resource for export of water, recreation, and culture. So that's a lot of qualitative information, and my challenge as a land use modeler is now to bridge the gap between this qualitative information and numbers that I can pull into a model. So this right here is just a GIF that's showing recent trends. This is a 50-year projection based off of land cover trends between 2001 and 2011. We're using the National Land Cover Database as our data set. And I'm showing you transitions between these particular land use classes. So forests, grasses, and crops, all transitioning to some level of forest, grasses, crops, and also development. Obviously, development is not really leaving. So what you can see here is a development clustering near Loudon up there, which is the very top, your right-hand side, that's the closest to DC. And along some of these highways, some of the transfer of development towards Winchester, which is where I live, which would be that other high population center, shown in gray. Okay, so we've got the recent trends, but we really want to incorporate those qualitative scenarios that were given to us by the stakeholders. So how is it that I do that? Well, it's two pieces. I first alter the temporal trends, and then I think about geographic trends. So that is, how quickly is this change happening across time? And then where exactly is it happening? So I'm going to show you just one example using one of the quadrats. This is the high population growth intersected with strategic planning. So we called this centralized development. This raster right here illustrates what we call a modifier raster, and the numbers are a multiplication of probability of a particular transition, in this case development, occurring closer to urban centers. So the darker red is an increase in 1,000 times probability, while the gray is a normalized 100, so it's equal, it's the same. This allowed us to tell the model to cluster development, but not necessarily change the rate of development. So the other one is the rate, so how much do we want to change over time? How much do we want that to increase? In this case, because it is strategic planning, we do have forest increase. So we do have some forest regeneration. So down there in the bottom left-hand quarter, you can see the transitions that I talked about earlier. And we still have a lot of transition going to development because this is high population growth. But we also do have forest regeneration. So the smallest width of the arrow would be like the recent trend scenario, and then it increases when we increase the rate. So the amount that we're allowing to transition per iteration into the future. The real question now is, okay, that's great, that's a lot of pixels on the screen, but what do they really mean for us? So here I just want to show you, instead of the entire region, I want to pinpoint a couple of locations. First, here's the general idea of how these scenarios differ. These are the same transitions I showed you before. So in some cases, we have more or less going to development. Those upper two are the high population growth, and the lower two are the low, so you can see how the arrows are thicker on the top two than the bottom two. And then also there's a differential in how much of each of these land use classes transitions to forest, grasses, or crops. So it's really following a trend of what does that scenario mean? What's the story that it's telling us? And how has it been supported by the stakeholder expertise that we've gotten in the past couple of years? Now, on the right-hand side, this is a focal point of the raster that we've produced. So this is a 50-year projection into the future. The top two, again, are the high population growth scenarios, and then the bottom two are low. So the red arrows is where I want to point something out to you where they differ. First, most obvious, you can see there's a lot more gray in the top. And then in those top two, if you focus in those two red circles, the one on the left-hand side has some development that's occurring along a road. The one on the right-hand side, it really doesn't exist to as much of a degree. That is the illustration of that probability modifier being pulled in. So we're allowing, in the case of strategic planning, for the development, same amount of development, to occur closer to the urban centers rather than being spread apart across the landscape. In the bottom, we kind of see the same pattern, right, down there in the lower corner, but we also see relative much less development over time. So on the right-hand side, you do see a clustering of development, rather on the left-hand side, it's kind of pockets spread out across the landscape. So for land use planners, conservationists, et cetera, and for the overall purpose of this project, we want to tie this into an eventual service that's produced by the landscape. And those services are supported by functioning systems. So what systems are being changed? So we conducted, just as an example for you all, to simplify it, we did a frag stats analysis in R, isolating forest patches in the future. So I'm gonna just show you one county here on the graph, because it's easier to communicate. But basically, what you can see is the base year, 2011, so that's actually in the past for us right now. And then 50 years in the future are the 4 colors. The colors represent the scenarios we had earlier. In the low population and high population strategic planning, the mean patch area is higher than the other two. So opportunistic planning, we are actually fragmenting and losing forest cover. However, you can also see a difference between the low and high population, right? Low population, you have more forest than high. And that all makes sense. So here's a way that we can begin to connect a service or a proxy of ecosystem function to land use land change models and maybe communicate these results in order to inform policy change and planning in an area of northwestern Virginia. So our next steps are to get more feedback from the stakeholders. We are at the end of the process of calibrating the models from a statistical standpoint, and now I want to be able to talk to people and have them tell me, is it realistic for development to happen here? What do you think should happen in this portion of the county? How do we deal with riparian areas? What about these other measures of function? So we're going to be setting up meetings and getting further along that process in the next couple of months. And that's all. Thank you very much for listening.
Thank you, Yara. So we are still running late, so we'll move on to our next presenter, David Lesmis,